as much control as we have on the design process now and the build process, how much is spent on change orders due to those problems on the job? And how do all parties make sure they're getting compensated? The offsite manufacturing process and the use of technology can help eliminate those instances.
Today's session is all about kind of step-by-step strategies for offsite building systems and panelization. I'd like to introduce our panel. We got Scott, right? He's right here. I'm looking down at the end. We have two Scotts, which is already causing me lots of problems, right? But we got two folks from MiTek, but they're going to be talking about completely different kind of aspects of the process. And the split in between them, we got Andy Viars. And Andy's going to talk about Simpson Strong-Tie and all the wonderful things that they do to pull all of our parts and pieces together and make them resilient and complete. They have a ton of material, so we are going to get started right away. You know, advanced building systems have been around for a long time. There's been a lot of promise. There's been a lot of hype. There's been a lot of bankruptcies. There's been a lot of challenges. So sometimes people, really ask, is this a fad? Is this just another, thing that's not really going to work out? But it's very clear that building science is really being able to kind of permeate our industry. It's changing the way we build. There's a better way to build. There's better materials. There's better components out there. And I think by the time we get done at 9:15 today, you're going to have learned something about how to build better homes. And I am going to turn that over immediately to Scott Reichensperger, and he is going to start us off this morning.
Well, good morning, everybody. Just a quick history about me, and I've been in the industry 40 plus years now, and worked for home builders, worked as a framer. I worked as an engineer for for connector plate company, and literally the last 33 years, both in the U.S. and over in UK and Ireland, I work with component manufacturers, and then just recently in the last 5 years or so, back with the home building side. And I say home building because it's about the whole process, the whole supply chain. And it's not about a component manufacturer or the builder, it's how you build better. So with that, I'm going to launch into talking about something called VDC. Hopefully you've heard that before. I'm going to use VDC from now on, but it's virtual design and construction for advanced offsite. So what we'll talk about is how do you precisely model the foundation, the building envelope, MEP, to eliminate the clashes, and then thus enable advanced off manufacturing. You can't have advanced offsite unless you have a precision model that's been solved.
Can you model the Sawzall to cut a hole in all the engineered joists?
Well,
I'm just trying to make sure I baseline my understanding of the technology.
No, but I know some guys that will repair that for a nice fee.
All right. Okay.
Okay, so I'm not going to belabor this slide, and some of my slides go pretty quick. Everybody knows when you get up in these presentations, everybody talks about the problems, and most don't get into the solutions. So I'll let you study it a little bit. I'm not going to talk about it, and we'll go on to the next slide. And I thought I would do this presentation a little different. I would talk about some of the success stories that are out there and the results of doing design, make, build, and that collaborative process. So this is a company out of Denver, Dale Cohen, and I hate reading from slides, but I can't help but read from some of these slides. Every project we build is a comprehensive modeled and MiTek structure. The MiTek model drives the manufacturer of offsite made roofs, walls, and floors, and creates assembly documents that effectively coordinated with the building design team and other trades, namely the MEPF. And they like to put F for fire on the back end of everything they're talking on the multifamily side. So those are some examples of some of the projects they work on. They go up incredibly fast. We go on to the next one.
So I got a question just real quick.
Sure.
I know we're really pressed for time, but who actually models with the MiTek stack? Is that the builder, or is it collaboration with MiTek? Or
so there's two things that go on.
Some people may not know that.
So you have the design. When I say design,
architectural design,
And let's include the structural engineer in that too, because he's part of that.
Got to
design.
stamp it. Yep.
Right. Who designs the components? That's the component manufacturers. And the roof truss, the roof, wall, and floor manufacturers. They're the ones that are modeling it so they can hit a button and drive the CNC equipment. Mm-hmm. So they're putting that in. It's drawn once, and often it's drawn again. And that's on the commercial world. The residential world doesn't matter. They're redrawing it because it has to be done with precision. If you don't draw with precision, you can't drive the CNC equipment. And we'll talk more about that in a little bit. Right. Another good success story here. Driving the industry forward may require prioritizing collaboration ahead of competition. Andy, I said I would mention the competition in here. It's to ensure offsite efforts are innovative and relevant, it is important to partner with builders, architects, engineers, framers, vendors, and the MEP trades to leverage expertise and create a learning environment. All of that drives, and I'll let you read the bottom half, all of that drives advanced offsite manufacturing. Whether it's roof cassettes, contented wall panels where you put in the window and door, the whole drainage plane's taken care of, and floor cassettes. You have to collaborate ahead of time to make sure that that solution is done with enough precision that you can manufacture it and then deliver it. And this is the other part of this, is it's deliver it in a sequence that makes sense for that framer.
It's interesting, you keep mentioning precision, kind of over and over, and some of the failures in our industry have been because we haven't had that precision flow through the process, right? So it seems like that's a kind of a hallmark here, is we have to make sure that the state of the module, whatever it is, whether it's a wall, whether it's a floor, whether it's a roof joist, whatever, we have to have that done precisely and accurately.
Yeah, the opposite, Tim, of what we're talking about is you develop a set of plans. It could be accurate. You take that set of plans and you present it to the field. You get bids back on it. And then you present that plan to the field. They go solve the problems, okay? You could be a production builder if you're working in that manner and you give that to the trades to go solve those problems, you'll get a different solution every time.
Yeah.
Because it's almost a custom home at that point. Yeah. Advanced offsite manufacturing. So this is the other benefit. 10% less material used in the build, 50% less time on site, 75% less waste, 55% reduction in rework. It's factory installed from the sheathing, the vapor barrier, and the windows and doors. This is a project up in Milwaukee. 70,000 square feet in less than 30 days in the wintertime. So, and you can see there's 4 cassettes getting ready to be lifted up. And then the wall panels that are being installed are the vapor barrier and the windows and
just so our audience knows, the difference between a wall panel and cassette is that you fully loaded doors and windows and vapor barrier, or? So
I'm going to call a wall panel, and I'll call a cassette a floor. Okay, and right. in this. Right. For our example, if we talk about I won't call that wall panel fully contented because it doesn't have insulation and it doesn't have any MEP in it.
MEP.
So design, make, build floor systems, if we talk about that. I love this statement. It's in our fully integrated model, moving upstream in the design process has significantly impacted significant impact on the efficiency of our off-site and on-site processes. The introduction of floor panels and utilizing a crane on-site for the walls, floors, and roofs continuously has reduced our on-site labor by over 40%. That's some homes going up in Jacksonville. They use that particular job, I think, is about a 4,000 square foot home. It was framed, including the stairs, in 9 hours. Another example, 15,000 square feet in 3 hours, 4-man crew, safely working through weather, reducing weather delays. Notice how white that background is. If you look at the blue, you'll see the big flakes of snow. That house or that set of townhomes is being erected in a whiteout up in Minneapolis. I love that picture. Let's talk about the design of floor systems. Again, I'm going to use the word precisely a lot. This is drawn with precision down to a 1/16 of an inch. It's modeled in MiTek structure, or other softwares can do this as well, but we're going to pitch MiTek today. And then you're eliminating the clashes and problems, providing for the MEP services, and detailed on-site placement plans. So you can optimize the cassette for that build. Something else to think about in design, and we'll talk about this a little more, is thinking about your building that you're going to draw, the home itself, or the townhome, or the multifamily. Is it designed for offsite manufacturing? Are you thinking about where you're going to break the walls, where you're going to break the cassettes up, where you're going to place the beams for that? You look at it, we get visual verification. You can look at the cassette and the cassette properties, and you can adjust. You get detailed manufacturing instructions out of it that the plant uses to build. And again, it drives the CNC equipment. And then you can get a chance to look at how that 3D BIM model drives the CAD/CAM equipment. You get that precision detailing. It's all built in that controlled, safe environment. Weather isn't a factor, and that becomes important. Another word that's as important as precision is consistency. Consistency on the build, consistency on the manufacture. That quality is paramount to have an advanced offsite work for you. Down to machine controlled nailing, reducing job site waste. So when you build here in the factory, all that waste gets used in the products. So there's none of that going into the dumpsters out on the job site.
You finger joint everything and remanufacture in the plant, actually?
Well, so think about it. If you're going to cut a long piece of lumber up in the factory,
yeah, you can reuse the end.
You're going to reuse the end. You're going to use it for blocks in your walls, for webs in your floor trusses.
I've actually seen finger jointing added to these facilities, right? So the smallest scraps actually just get.
There are people doing that too. That's becoming
finger jointing.
That's becoming a bigger trend.
So I got one question though,
Sure.
is we keep talking about precision, and we're talking about, and if I get your nomenclature right, you got wall systems, roof systems, cassettes, right? You have all these different modules you can put together. Is there a best practice about, do you have to do all of it, or can you just do, my question is, if I do roof systems, but I have a stick-built walls, then my stick-built walls aren't precise. Now will my roof system or my cassettes really fit on them, right? Or do I have to do everything? Do I really have to do walls, cassettes, roofs, all of it together? Is there best practice there?
And the answer is, Tim, you're right on. You can do each one of those products individually, a roof system, wall system, floor system. I will say that if you just do roofs and you don't do walls and floors, somebody's still solving that problem on the job site.
Of the gap between the two.
Yes.
One's precise, one isn't.
Right, and they'll solve that the way they want it. I was taught by my grandfather, right?
Yep.
And that was the first builder I worked for. I could do it the way my grandfather did it, and that's how this industry has grown, right? It's who you work for is how you're going to solve that problem. The next crew that comes in is going to solve it differently.
All right, so now I'm going to talk about the biggest nemesis.
Sure.
What about the foundation? Because the way I always look at it is we pour a non-square, non-level, non-deprint foundation, and then we build a house to match it.
Let's talk about foundations in a little bit. I do have a place to talk about those.
Okay.
All right, but if the foundation's wrong, right? And that's one thing we'll hit it right now. One of the things that stick framing and solving the problems on the site takes care of is
accommodation.
Well, yeah, it does. It allows you to work around that problem and allows you to cover it up.
Yep.
And literally that's what you're doing. You're covering up the problem. BDC project collaboration starts with the builder and the architect. It goes into, and this is this part where you're developing that 3D model that can be used to precisely drive the advanced offsite. solve the problems in the model before you actually get to the job site instead of at the job site. This collaboration that happens is where the roof, so you got the architect, he comes up with the conceptual, that base design. It could be 2D, it doesn't have to be 3D. You can take that design into this VDC process where you've got the systems manufacturer, that roof, wall, and floor systems, working with the architect and the engineer. They're value engineering that building envelope, making sure that all the MEP works, make sure that it works structurally, that you take out extra footings for walls that don't need it. Maybe you put in a footer for a post instead of a whole wall. You can remove a beam if you're using roof trusses or floor trusses because they can span a greater distance. It's working through that in that small team, and then you take that solved model. By the way, a lot of people say, well, we do that. Normally what happens on that flow is you take that set of plans and it'll go out to bid, and it's a linear process. It's not a collaborative process where at design stage you have that engineer and architect and the systems manufacturer working together. I may also throw in there the framer. The framer's the part that does all the installation in the field. He's important too, and that takes me over to this next segment in the collaboration, where that framer takes that set of plans along with the MEP trades, and you give it to them solved, and you say, what would you do different? Okay, they're not very good at being authors of that 3D model, but they're pretty good at being a critic of it. So if you hand them that solved 3D model, you'll find that those trades will say, well, I would do this different. This is going to save me time here. And they'll allow you to go through that and fine tune that. And that's this process here where you've got that continuous feedback loop going back into the engineer, builder, architects, and the systems manufacturer. So I put down there at the very base, the foundation, okay? It is so very important that you detail that out, including the rough ends. If you don't stub out the plumbing correctly, you'll find that you'll have a wall where it needs to be placed, and that stub out's coming out in the wrong place. So the foundation is critical. Also, you mentioned the levelness. Otherwise, you're going to spend a lot of time going around and shimming those walls, right? If it's stick frame, you're still going to shim those walls. Nobody cuts studs. Not very many people cut studs to length to fix the waves in the slab. All right, that's this collaboration piece is time consuming up front. Okay, this isn't what you're doing today. You're gonna spend more. All the participants and the constituents in this are gonna spend more time up front. And so when you're thinking about this process, it's about partnerships. Okay, it's developing partners with those trades on the MEP and the framer side, as well as your systems manufacturer, your component manufacturer. Notice I'm morphing from component manufacturer to systems manufacturer. One, the abbreviation for component manufacturer to CM, which in the home building world means something completely different. But the systems manufacturers, I'd love to change the game and to start thinking of roof, wall, and floor systems, better yet, building envelope systems. With that, one of the results of doing this is there's your traditional method. We look at this and we're going to go ahead and use components, and we're going to manufacture them off-site. So we're going to do things in parallel. While you're pouring and curing the concrete, you're going to make the roof trusses and the wall panels and the floors. And this process is time on site. And then this is the advanced off-site construction, this VBC method, VDC, somebody can't spell. This is where you add in that collaboration. It takes extra time up front, but look what it does to your cycle time on the job site. The more content you add into into the trusses and the walls and the floors, the shorter that time gets out on the job site. The other thing that happens is you've pre-planned where your MEP goes. You've pre-planned where everything is going and how everything's going to go together. The time, the number of callbacks that you'll have using the VDC process will go down dramatically. I recently worked on a job where we were able to get rough-in inspection done in 7 days from the start of the frame. So it was phenomenal. There were no callbacks on that. The design, make, build advantages, and then solving the building before it's built enables advanced off-site manufacturing and consistent on-site installation. Reduce, eliminate callbacks. Enables a tighter schedule for the MEP trades. So think about that. You're dried in, so maybe your frame takes a week, and you're dried in and you're ready to move to the rest of the trades. But you've pre-planned where everything goes for the trades, for all of the MEP. So with that planning, you're able to say, okay, HVAC, you're in here the morning of, and you're not planning days. I know that most people won't schedule the trades in there together. Sometimes they get in arguments about that. But you schedule in the HVAC in the morning. You got the plumber in there in the afternoon. The next day you're doing the electrical. And there's no reason in bigger homes or buildings that you can't have them all there at the same time, because they know where their product are going to be installed. So another big deal is there's less loose lumber on the job site. There's less lumber to go missing. There's less waste. You build more with less on-site labor, faster cycle times, less waste in time, fewer trips to the job site and calls backs, and you're reducing the total cost to build for that home. So collaborate with your component manufacturer to design the roof, wall, and floor systems, and develop an optimized, error-free envelope with MEP. The bottom couple of pictures there are showing some of the work that our services team has done with some of the builders. And the bottom left is an actual picture of one of our sales guys' home where he modeled everything in our software, and that's the as-built to the right. That's that picture on the bottom left. So how can MiTek help? Use MiTek's design and modeling services, 2D to 3D. Use MiTek's design engagement team for value engineering. We have a whole team stood up that goes out with, it's generally with a production builders and multifamily to value engineer that product and work with them and their architect, engineer, and component manufacturers. Use MiTek's array for Revit options management that allows you to do options on options within Revit.
We're going to move right over to, we got to go quick. We got lots of stuff. Are you ready, Andy?
We'll go with it. Nice job, Scott.
Because I know Simpson has a ton of different products, all kinds of great stuff. Saw a lot of cool stuff out at the International Builder Show this year as well. So
we're definitely jumping into new ventures, that's for sure, outside of just the typical connector space. So I've been with the company 21 years, very blessed to be with Simpson. Focus was on connectors, fasteners, but now I'm in that technology and equipment space. So let's jump right in to talk about that off-site construction and that off-site manufacturing process. We'll reiterate a little bit of what the need is, and then we'll talk about the steps of entry. You know, it's very important to talk about what level do you want to go into that off-site, and then how do you get there? And then a couple other points on what that end value is. For this part of this discussion, we're really going to focus in on walls and that framing aspect of it. So we're going to refer to that off-site product as there's pre-cut frame packs, that's loose lumber. There are your traditional prefabricated wall panels, but then that multidisciplinary wall panel.
And a fully loaded wall.
Fully loaded wall. So how do you plan for that? So what is driving that need? You know, Scott mentioned about the need for shorter build cycles, the quality of the labor that we're able to go hire. A big driver is the room on the construction site. You know, that's not just an effect on safety, but how do you get material delivered? You can actually make the build cycle longer because of that challenge. So how do we prepare to lessen the build cycle on a tighter space? Waste and theft, right? Theft is still occurring in different parts of the country based upon where some allocations are hitting. So we think offsite manufacturing can be a contributor to reducing that. And safety. Safety is a very expensive part of the build. Yeah. And a lot of builders in the community are focused on how can reduce that safety cost. Offsite manufacturing can definitely help drive that. So how do you enter into it? This is key. We've seen a lot of builders and a lot of manufacturers go all in. It's worked in some regions and for some companies, in some areas it hasn't. So we feel that it is crucial for the builder, the framer, component manufacturer, if they're wanting to go fully integrated, find that trusted partner, okay? That facilitator to help guide you into that offsite manufacturing and driving efficiencies at the builder level. It could be MiTek, it could be Simpson. There are a lot of consulting firms out there. So you have to find that right partner that you want to work with to go steer towards that success. As part of that, I mentioned earlier, what is the level of entry? You know, offsite manufacturing can be modular in concept. Maybe we start with walls and then we jump into floor cassettes, roof cassettes. You get into the multidisciplinary walls. What level of entry best fits the savings that builder is looking to gain? So that's where the trusted partner, having that so that is mutually beneficial, okay? So once you identify that, what are you wanting to accomplish? Is it just savings in material? Well, maybe it's just walls that would be the driver of it. So you go through, some might say a Kaizen type event, right? To an A3 to where you can truly identify what that mission statement is that we want to go achieve. And then the game plan, right? Before you go be successful, you got to have a game plan. And as part of that, you have to collaborate. Scott mentioned collaborate quite a bit. That is key. You know, I look at a lot of the building process. I've used the analogy. It's kind of like a marriage. Marriages are successful because of communication. Well, improvements in the build process are just that. If you're not communicating, we're not going to gain. Right. So getting everybody to the table to talk through that collaboration of what the builder is wanting to achieve will help drive that success. As part of calibration, you're going to hear me mention single source of truth. You know, Scott mentioned about the BIM model. You know, everything now can be in that digital format, and we can, in essence, build that model prior to that job site. Talk about a reduction of costs. Sometimes a model might get built 3 or 4 times before it's dialed in. Well, let's work to use the technology that now has presented itself to capitalize on that time. So, and then lastly, we call it pre-ignition meetings. You know, we've collaborated on what that model needs to be. Let's make sure the process is dialed in. What car are we going to go drive to get down the road to make sure we can carry everything to go maximize the best of a vacation, so to speak, right? Who's going to be with us? Who's going to be driving first? How do we stage this process to go win?
The collaboration piece seems to be, you know, we heard so many times that the trades will sabotage, you know, this transition to a modular build. And I think the issue there is because you haven't communicated with, and you haven't brought them in as partners. And if you can bring them, both of you mentioned the same thing, and I think that's a critical issue. We've got to bring the trades in as partners if we're going to make this transition.
It's a must, Tim. You know, we like to say mutually beneficial partnership. When you talk about wall panels versus stick framing, for instance, it's a give and take with the framer. You know, the framer they will feel that, yes, I'm losing control, so to speak, but they have gains that they can have as well. And you have to have those conversations. Transparency is a key driver there. It's give and take. But at the end of the day, if we shorten the build time, builders building more homes, framers building more homes, time's money. Yep. And so communication is a driver of that. So let's talk about that single source of truth. You know, there's software that you can do it all in one. There's software that can bring models in. And, you know, we talk about we have to do this early in the process. So as the building community is starting a hard transition into that Revit space, a lot of the new draftsmen coming into the industry, they know Revit more than they know ACA. Well, we can capitalize on that. So if we're taking our model into that Revit world, then how can we bring in an MEP design and the actual components and objects there? How can we bring in the components? the electrical, the plumbing. In this image down at the bottom, we did not include the roof components. You see a floor system. We pulled the electrical and plumbing out because there'd just be too much there in that small space. But the ability to bring all of these components in prior to a build allows that builder and A&E to review for clashing, make sure structurally we have framing where it needs to be. And then as we do that, what changes to these other designs might there need to be? So we want that single source of truth. The builder needs it, and that is what is going to drive all those efficiencies prior to the build. There is equipment in the industry that allows you to take that model out to the job site.
I love this piece of equipment.
So it's, there's 4 or 5 manufacturers that have a marking system as they're cutting the framing material. So we can literally take that 2D model into a BIM environment to where we have all the objects framed out. Those, when they export a file into a CNC and cutting equipment, you can cut to that precision, but you can also print based upon that geometric data that's coming out of that BIM model. And it's not just about framing. Obviously in the top right, you see a picture of the connectors there, but you print conduit locations, right? Gang box locations. Where does a plumber need to drill? Bearing locations on plate to make sure we are aligning floor trusses and systems in the right spot so that we're not sawzawing, right? We're not having to go get that expensive repair done. I like to think that as much control as we have on the design process now and the build process, how much is spent on change orders due to those problems on the job? And how do all parties make sure they're getting compensated? The offsite manufacturing process and the use of technology can help eliminate those instances. But we can take and you can print structural details straight onto those framing members to increase the frame time, but also there's inspection gains as well. So, key contributors. Technology literally is the fuel that can help drive this engine, okay? As a builder, there's a lot of push right now to get control of the plan, the model, the elevation, the structural details that go within it. And working with the component manufacturers as they're going to build out those models, if we get control of those up front and we use technology to help make sure that that plan going out to the builders in the different regions is aligned, then you're getting into what we call exactimating. We talk about eliminating waste. Estimating is good, but we always get overages to the job site, and let's face it, overages end up going over to other jobs, maybe for a different builder. So if we can use technology to get into that exactimating concept, we're going to reduce waste prior to getting there, and then the savings on the back end. So I did put the Revit logo there. There is software out there that allows the collaboration without having to do a hard transition on software. So this is where a trusted partner can truly help make sure that there's an expense to transition from a digital mindset for a builder. How do we make sure that we can minimize that effect in addition to other expenses that come with it? At the end of the day, there is a gain, but you have to think of every aspect of a transition to offsite. So, and then obviously we have the Easy Frame system there that helps interpolate that data and turn it into the reality of framing.
I mean, it does seem like you're offering an easy on-ramp for builders, right? In that if I'm a stick frame builder, always been a stick frame builder, I could at least move to Easy Frame. I'm still getting sticks. Mm-hmm. They just happen to be already cut exactly to length, and they happen to be marked exactly. So as you said, inspection is easier. The trades know what to do, right? It's just an easier build, but I'm still stick framing.
Absolutely. You got to take them to the water. And they determine how much of the water they want to drink. And if they have that first glass and they see the gain, it's more inviting for them to work with you to talk through what's the deeper dive, what's the next improvement that we can go see together.
Why don't you just send all those sticks pre-nailed and assembled?
Absolutely. Absolutely. You let them taste it first. Sometimes that is the path to entry for a builder to go maximize on the saving opportunity.
Now, I got a question for both of you on full wall panels. Are you actually doing electrical pull-through drilling and nail protection plates and all that kind of stuff on your wall panels, or is that still part of the trade space?
Let you go ahead, Scott.
Yeah, and so yes, you can. Okay, is the answer. You can pre-drill. You can put in the protecting plates. When you start looking at pulling wire through, there's other problems to solve. And not that you can't do it, but I think there's a step that you're going to take where if you pre-drill and you pre-route holes, then you're giving, like Andy said, you're giving that trade a path on where to put things. You're putting more instructions in. Here's the hole that you're going to run through.
Right. You're not going to drill another one. You're going to run it through the hole that's there.
So there's an advantage to doing that. So that's emerging, I will say right now.
Because in full MEP, it's there. Right? It shows where the wire is supposed to go.
Right.
So the question is, do we really prepare at that level and provide the kit?
And the saws that Andy talked about, that the ability to mark on that lumber allows you to mark, hey, drill here. So then you can drill at the component manufacturer, or at least the plumber or electrician knows where to drill through based on the instructions on that member.
Right.
You can mark the key identifier, is what we're reference to it. It's important to know garbage in, garbage out. So the level of detail in the design is going to dictate what that gain is. And yes, there might be a more expense to the design process early, but if that structure is getting built 4 or 5 times, and then the gain on the back end, not to mention the savings of not having to go to rework based upon the learnings during the build, that's where the win occurs. So there obviously is going to be an upfront cost when we're talking about increasing the level of detail in design. The back end gain far outweighs that.
So if I can interject,
Absolutely.
Andy, one of the things that becomes really important is on that collaboration piece is to get buy-in from the MEP trades and the framer. And this is how we're going to manufacture this for you to install. So they agree to those changes. They're a part of those changes in that process. And when it comes out on the job site, they're not re-engineering that on the fly. It's important to get their buy-in.
And to add to that, a lot of the MEP trade, based upon the level and size of that contractor, is already designing and doing their layouts in a Revit-based application that they can share. So I actually think as the building industry is transitioning, the residential building industry is transitioning to Revit, you will get an increase in communication from the MEP trades and less pushback. So great question. So what's that value that is gained? Trade collaboration. I mean, we have said that numerous times at both levels of the presentation here. Plan control. Get control of your plans, the elevations and the options to be able to work with those suppliers to increase that collaboration. More accurate estimates, exactimating, less waste and theft that hits that job site. The rework reduction is enormous. You know, who is paying for that expense? Sometimes it is not getting paid for. So we see a reduction in that need as part of offsite manufacturing acceptance. Then the quality, right? When you're manufacturing in a controlled environment, you will see an increase in your quality control. Safer job sites. You know, we see it all the time, tripping over lumber, tripping on extension cords. You're going to have less tools out on the job site as part of this process. And then you're going to actually build a better relationship with your local inspectors as part of this. We're going to reduce your build times, and then ultimately you're building stronger partnerships across all of your trades. All is a result of the offsite manufacturing. So again, it's about driving those efficiencies, controlling the front end, working with your suppliers to make sure they are getting a benefit in addition to what everybody is trying to gain. And when everybody gets in that same bubble, that is a success that occurs. That offsite construction drives efficiencies, not just for the builder, but for all trades involved.
Fantastic. Scott, you're going to close it.
Ready.
And you're going to say, but they said everything. There's nothing else to say.
Issues right up front. Anybody remember who this guy is? Anybody but me ever worked for Pulte Homes in their career? Started there 36 years ago and was there for 9 years. That's Bill Pulte doing a project in Guatemala that he became very close to, Catholic charities down in Guatemala. And that's Bill. The smile like that, never a tie on him, and he was I've had some great mentors, and Bill was probably the greatest one. So objective current reality here. We're now on what I call OffSite manufacturing revolution cycle 4. And in my longer slide presentations, I lay out all what those cycles are. It's pretty interesting. But we're on cycle 4 of all the revolutionary product and process that's going to change the world. Okay? Bill Pulte from about 89 to 2017, he used to do this presentation to all the new people about the applications of manufacturing technologies to home building that was going to change the world. And back in 89, he would hold up his fingers and go, it's about this far from happening, okay? So we're talking 35 years, 36 years ago, this far away from happening. We were Detroit-based people, so boy, we knew manufacturing and we knew what happened to the car companies in the 70s and the resurgence in the 80s and 90s. So we were all over that. In 2017, just a few months before he passed away, I visited Bill. He wasn't working in the company full-time anymore. He's still on board, I guess. And I recalled to Bill that big present, the 2-day workshop he would do, which was really amazing. Wish we had it on video. And I'd say, Bill, so how far are we today from that revolutionary manufacturing technology that will change home building forever? And he thought for and he says, we're about this far away. And we're still about that far away. A lot of things happening, as I said, a lot of bankruptcies. There was a Home Innovation Alliance survey, HIA, and I'm going to see if there's this is a couple years old now, but only 7% of builders see manufacturing technologies applied to home building as a solution to trade shortages. 7%. It's just mind-boggling. But this is really very old stuff here. And there's some examples. Here's my favorite examples, okay? Here's 2 homes. They happen to be in a town called Rushville, Indiana, about halfway between Indianapolis and Cincinnati, Route 52. And does anybody recognize these homes? Who built them?
Sears.
Exactly. In the town I live in now, Plymouth, Michigan, about halfway between Detroit and Ann Arbor. I drove a couple of guys around one day from MiTek and pointed out 20 or 30 of these homes. And they were great homes, and they were built. They're great homes. These homes today.
Still great homes. Yeah, they're still great homes.
Yeah. These homes in Plymouth, Michigan are selling, you might find one for $450. A lot of them around $600, $650 now. They've been maintained, fixed up. They're beautiful homes. Well, the one on top, I lived in from birth until 6th grade. On Willow Street, 1201 North Willow. You know, I can't find my car keys, but I can remember it. And then on Perkins Street, around the corner, that was my grandparents' home.
Oh, how
and so we didn't know they were Sears homes, I guess, and they were great homes. Unfortunately, Rushville was this town with all elm trees. It was just beautiful. Everything was surrounded by death, and now they look kind of like they're out on the prairie. Not quite as pretty, but both those homes have been maintained and doing great. So Sears, few stats, a lot of you know this, but you see they did 70,000 homes over about a 30-year period, 35 years, 30,000 pieces and parts, pre-cut, numbered, everything included. You know the phrase, everything but the kitchen sink. Well, they had the kitchen sink. New framing methods, compare that to today. Any of you do ReadyFrame? By chance? Anybody? Yeah, ReadyFrame's a great system, but it was nothing compared to what Sears did 100 years ago. So 100 years, look at our vehicles after 100 years. Look at our electronics, anything, airplanes. So we haven't gotten as sophisticated as Sears was 100 years ago. Okay, real world today, panels, inefficiently built panels is the norm. I'm sorry if any of you are panel manufacturers. There are great exceptions out there. There really are some great ones. But normally, I walk houses constantly all around the country. We see an awful lot of inefficiencies in them. Foundation consistency, which has been talked about, it's a real problem. But I had 3 experiences that really got me going on this, which was one around Louisville, one around Buffalo, and one in Missouri, of builders that were still stick building instead of trussing their roofs. And in each one of those cases, I got one of their design guys and one of their really good field guys and a purchasing guy, and we went out and walked those homes and came back to the office, And it took us a total, including the travel time, of 3 hours at the most to convert all 3 of those builders to doing trusses. That wasn't the plan. I wasn't with MiTek then. We sold to MiTek about a year ago. But the point was, if you really know how to evaluate things, it wasn't difficult at all to show, no, the trusses aren't more expensive, they're less expensive. And so that really got me going. And then Scott and I met at a DuPont deal they called us into. And COVID was shortly after that. And he and I spent tons of time on the phone in COVID, because we really weren't that busy, working on this issue of a measurement model for on-site versus off-site. What would really make the difference? What would show people true total cost of it? And both Scott and Andy gave examples that you'll see how well they fit into this. Dr. Deming, I don't know how many of you still, if he's probably not even being taught anymore. He was on the cover of Time magazine once. I had the incredibly good fortune of getting to know him personally. He used to do a thing where he'd stand in front of a group when he was 90 years old. That's my goal, to be doing that when I'm 90. He'd look down at his shoes, his big, heavy wingtip, floor shine bromes. He'd point out them, and he'd look at the group, and this would go on for several minutes. You think, did he have a little mini stroke? Has he lost it finally? And he'd look up and down, look down, these big baggy suits he'd wear, and he'd go, I won't do his voice. He'd be like, somebody asked me. But
It's kind of like Yoda. It was
yeah, he was the Yoda of manufacturing, absolutely. But he'd say, somebody asked me, and he'd point down the shoes and look up, point down and look up, what these shoes I'm wearing cost me. He'd look and look out. This would go on for a couple minutes. And he wouldn't say anything. Then he'd go, I told him, and I'll do his voice now, how could I know? I haven't finished wearing them yet. Then he'd look at the group, 300 people. He'd say, talk about it amongst yourselves.
Yep.
And I got to see him do that, his 3-day workshop, 3 times. And I go sit down. He would go sit down, and we would just like, oh, okay, let's start talking about it. And then we all feedback. It was amazing. That one Dr. Deming bit is worth a degree in purchasing if you really study it and you really get it. So as soon as you say, I haven't wearing them yet, you are absolutely showing that there's a lot of other factors we got to consider rather than the bid price. So if we don't, the thing up above here, the only thing that buying on bid price alone guarantees is that you will never, and I mean never, operate by lowest total cost. You will get lucky occasionally, and the bid price will be the best overall total cost, but it's rare. So if you're doing it by bid price and being pressured by higher-ups to do that, all you're doing is adding money to the cost of your house. Bid price is one of 10 factors that we teach that you've got to look at, okay? Without it, total cost, you can't make right decisions. Anything less means sub-optimization or outright failure. I have concluded that our inability, the last one I'm going to read, our inability to understand and measure true total costs has been and will continue, if we don't start paying attention, as our biggest single obstacle to the implementation, broad implementation of components in home building, which will greatly reduce our cycle time, reduce our trade burden and shortage. So that's where we're going with this. So how do we measure? A guy named George Box, I'm sure you remember George Box. He was actually a professor at University of Wisconsin, but used to go to conferences and stuff. And he had a great saying. He'd say, all models are wrong, some models are useful. Okay, so remember that. We know all these models here, they're not 100% accurate all the time. There are too many variables, and it varies so much geographically, even culturally in the company culture. But today, I'll say better than 90% of builders, if they're gonna, let's just take panels, whether they're light panels, just the wood and maybe sheathing, to heavy panels that maybe come out with windows, doors, house wrap, maybe even pre-drilled. Whichever ones you're talking about, 90% of builders only look at labor material, and maybe they add in the equipment costs. But that's what 90% of it is. And you're prohibited from making the informed, correct decisions if that's all you measure. When you look at panels, what, 95% of the time, guys, if you look at only labor and materials, panels are going to lose. Well, but as it turns out, you don't have the right information. So here's the big thing we've been working on. Scott and I actually started working on this on our long COVID conversations well, that's 5 years ago right now.
Yeah.
5 years ago. So we finally came up with this initial template. This is the 3-year ago edition. And we had direct labor and material, of course, you got to measure that. Design and engineering costs, on-site waste, builder admin and overhead, important. VPO, variance, where you call them EPOs, FPOs, by any other term, it's variance. And tracking that variance, which is something that people don't think about. You gave one example of that, Andy, where that can really go down as a result of using components to a greater degree. In-process rework, you acknowledge that. It's amazing how many similar things there are between Simpson and MiTek in terms of our thinking about this. It's probably...
Except one's way better.
Well, our colors are a little better. Okay. And in-process rework, which nobody measures. Nobody, I don't even have to ask if you've ever measured it. Nobody does. And this is a distinction that occurred to me one day. It was like I was like, oh, I don't know where it came from. There's plan trips to plan to make a house. And then there's the wasted trips. The wasted trips that otherwise should not be necessary if things had gone right in the plans, in the specification, in the delivery of materials, the right labor, et cetera, theft, all the things that can go wrong that you have to really differentiate between, because you can save on both. You can save on planned trips and you can save on the wasted, what should have been unnecessary trips. And that's a critical distinction. Cycle time is so huge and virtually nobody measures it when you're comparing these things. We were talking earlier about, Andy does 100 houses, I do 100 houses. I take 180 days, being honest, to build them, which is very common these days still. Andy does it in 90 days, which used to be 35 years ago. That was kind of like the Pulte standard. You should be able to build these homes in 90 days, and they were good homes. And you actually, the builders, generally speaking, that build them faster have higher quality. We've got tons of data on that. Well, if he builds them twice as fast as I do, he only needs half the capital that I do. Is that a big deal? Okay, it's a big, you're not, it's a big deal. Have you ever used that factor when you're comparing on-site and off-site? Actually calculate it and used it? People kind of intrinsically know about it, but they don't go to the trouble to calculate it. Well, guess what? We have a template for you that we'll send to you. And I believe it's in the things, but let me do this real quick. It's really, so I'm doing this stuff so fast. Scott, S-C-O-T-T Sedam. It's kind of like four-door sedan, but with an M. Okay, so Sedam, S-E-D-A-M, at MII.com. So M like MiTek, II.com. If you will send me and just put send templates in the subject line. We'd like to know who you are. We're going to, probably in a month, we're going to have it, so you have to go to the website and fill out the stuff to get it, but it's free. We give it away. So please tell us who you are, and my only thing is you got to show me 6 months from now how you used it. And if you don't, I'll bug you about it, okay? So cycle time is massive. Warranty costs, obvious, but people don't do it when they make these calculations. Equipment, you got to usually have to have a crane. There's some ways around it sometimes. And then safety, which you both meant. Safety is huge. Right now, how many of you have your state worker comp factor, some people call it mitigation factor. It's either a 100, could be 115, which means you pay 50% over. 80 means you pay 20% under your trades. Or some people do it like 1.15, same thing. How many of you actually have it? If I call the office and you could get it for me and sent to me in 15 minutes of your 20 major trades that work on your sites. How many have that for all those trades? Raise your hands real high. Okay, I learned this 35 years ago from Mike Rhodes in Chicago. I've had it in my 27 years of running columns for Professional Builder. I've probably mentioned it, no more than 100 times. I guess it just means no one pays attention to what I have to say. That is the only thing you do. A year from now, if I see you here, you're going to come up and hug me and you're going to buy me dinner. You will learn so much from that. But the trick is, you can't get it from the state. Your trades have to give it to you voluntarily. And a lot of them will be afraid to do that. But if you have the right support and the right culture, you do it, you all start to learn from it. So safety is critical. What I'm going to show you now is the super simplified version. We are almost done with the Excel template that has all the math in it and does this, but we decided we need to make a stage 1 simpler version and the more complex version. So we're going to send you the simpler version, and if you do that and send us this, well, you don't have to have your name on it, but we want the data to help you use it, then we're going to send you the fancier, more complex version, okay? So after working on this for 5 years, here's where we are, okay? On the left are things are more quantitative that you probably have numbers for right now if you go look for them. On the right are more qualitative. And that continuum is, the ones in the middle, you could maybe go either way. Maybe you have a start on it, you have some things, but you're not ready to quite put it into your formula, and that's okay. So if you look at the bottom on the left, you can do dollars plus or minus. And in the middle, you have dollars plus or minus. And then on qualitative, we're just doing pluses and minuses. Over time, you might be able to measure it more. And as you measure it more, you'll be able to move these to the left, get more and more data. Now, I don't have time to go through all 24 of these on here, but here's my challenge to you. Look at one of those and tell me it's not important. Tell me, when people say, oh, Scott, you got to make it shorter, it's got to be simple. Yeah. I say, yeah, great, I'd love to. Tell me which one to leave out. Which one did you leave out? Safety? Really? We all know we had a project recently that cut 10 days out of the framers being on site. Well, 10 days without the framers on site, you think after a year safety is going to get better? We logically know that's true, but you all probably don't have numbers for you yet. Over time, you can develop those. So that's all I'm going to say that right now. I'm going to send you the version where you can put your numbers in. It'll do the math for you, okay? And if you don't have something, for example, you don't have anything on in-process rework now, well, then leave it out. It's okay. Do what you have. But over time, you're going to get these. Now, we do these Excel templates that we give away, and here's pictures you can't see, but I'm going to blow them up a couple real quick. So that previous one with the 24 factors, that looks like a lot of work, doesn't it? I mean, that's oh, geez, 24 factors. But again, they're all important. And what happens as you start to get more of those factors, that equation where you looked at labor, materials, maybe equipment, because that adds cost to it usually, those factors, the equations start to change. Your equation starts to change from being stick-built for panels, for example, or doing roof cassettes or floor cassettes, and that's not really penciling out. You start laying these other factors in, and you know what? They're going to pencil out, and then some. And it really is going to make a difference. So what part of it? We talked about that. Without the leg and brain work, you're going to make continual mistakes. If you just do bid price, labor and materials, you're wrong, okay? You don't have enough, or you're just guessing. You don't have enough information. Bid price means nothing in the absence of the knowledge of true total cost. It's not just that. It will lead you astray. Okay? There's nobody in this room who's been in home building who can't give me, if we had time to over lunch to talk or something, or over the phone, you went to the phone, 10 examples where you were a victim of a low bid price. And it was the gift that kept on giving. It just cost you. Okay? So when we solve the obstacle, we're going to make a lot of the other problems go away. It's going to happen this time. So what I'm going to do, I will send you these that are all fleshed out. Matter of fact, I noticed this morning, we have slightly newer versions of these that give a little more detail. We have something called the Save Day Calculator, okay? Now, I'm not allowed to get up and walk around. It makes it really difficult. I can't read it. So this is an example of a builder on the left that we just did one save day. We do these week-long things called Lean Building Blitz, and it blows everybody's mind, doesn't it? The true total numbers of what is a day in the schedule worth, okay? And can you read that one in the lower right, what that number is?
75,000?
75,000.
Okay, so for this builder, $75,000 for a day applied to all their houses. Oh, I got a bigger one next. Sorry, I rearranged all these. Okay, so there's one day. By the way, the whole key in this, when I was at Pulte 36 years ago, this was beaten to our heads. And that's what the biggest part of this is. The key is the absorption of fixed cost. Okay, so if you improve it, these guys were at, I think those guys are 150 days, if I remember. If you improve to 120 days, and we're going to take, is that 14 out? Down in the bottom, how many days? 14. Yeah, I thought, and then, so now we're up to what? Is that 1.3 million?
Yep.
About 1.3 million? And you're starting to get really interested in, maybe we ought to work harder to save those days, okay? And then if we look at 90 days, which again, 35 years ago, and all our progress, that was pretty much our standard, what we ought to be shooting for. Now, not all divisions did it, but we had Chicago doing it, doing more starter and first move up, and we had Michigan do it, second move up, even third move up, 90 days, like clockwork. And they were great houses then. And now we're up to what? $4.2 million. Now that's assuming a perfectly elastic system. Remember that from economics? And you're able to recover it all. Now, so just say, we can't get it all. Let's get half of it. $2 million. Maybe we ought to work on this. So we're going to send you that. You're going to find it really interesting. The other one we're going to send you is called the Trip Cost Calculator. How many of you ever sat down with your trades and suppliers and calculated out what a trip to the building site costs? Do you know what the average from our 250 lean building blitzes we've done over the last 17 years? 250 of them. You know what the average number of extra trips lumber companies make more than they should have to? 7. They make 7 more trips than they should have to. What's that cost them? What's that cost you ultimately? So we have a way to help your trades figure that. There's the one. Figure that all out. We're going to send that to you. Try it. You'll find it quite remarkable. You want to be the builder of choice? Help solve that for your suppliers and trades. They will love you more than any other builder. Okay, now we got back to the last slides here. So I end this by telling you what Dr. Deming always said at the end of his presentations. He said, all we have to offer you is profit. Okay, so send me the email. We'll send you the stuff. There's the email. Thanks
very good. Scott, Andy, Scott, thank you very much. What a great panel. Lots of expertise. Well shared with us.